Hello, everyone. Good afternoon. Depending on the time you see my video, whether it's afternoon or morning, yeah. But I hope you are doing well. Now I will introduce our functions because I'm just giving introductions to the topics because these topics are connected to each other. I talked about quadratic equations, but I didn't plot the quadratic functions. First of all, you have to solve quadratic equations, and then you have to know quadratic functions, and then you plot the graphs. And of course, this applies to linear functions. In coordinate geometry. So there is the aspect of a function, okay? Because for you to plot a graph, you need the domain and you need the range, okay? Now these two aspects are found in functions, okay? So let me introduce a function. So this is a function, okay? A function, think of an input and output, okay? You have input and you have output, okay? For example, if you are preparing in Shima, okay? If you're preparing in Shima, you have water and you have meal as the input. So when you get the water and meal, you put it you put it in the pot, and that's an input, okay? And when the water is hot, you mix it, you have the output as in Shema, okay? So that's a function, okay? You have something as an input, and then you expect to have an output, okay? You put something, okay? For example, if you go to a shop, you want to buy something, you give money, you give cash. When you give money, that's an input, and then you expect to get something like soap. You give 2 kwacha for soap. 2 kwacha is an input, and then you get soap, okay? That's an output. So that's a concept of a function. You need to have an input and also output, okay? So let's take x, for instance, as this input. X represents inputs that we don't know, okay? And of course, when we put x into something, okay, we get f of x, okay? Meaning f depends on x, okay? For you to have this output, you need to have the input x, okay? Now, in mathematical terms, this input is called the domain, okay? And then the output is called the range, okay? It's called the image, okay? It's called the image because it's coming from the input, okay? Now, this is called the image, okay? So it's the image of x, okay? So now this is just the explanation I can give you. Like you have, for instance, this is cash, okay? You have cash, like 2 kwacha. Then you want to buy soap, okay? You want to buy soap. So you pay 2 kwacha for you to get soap. So you need first of all 2 kwacha as an input, okay? And then you get the output, soap, okay? You give someone, the shopkeeper or the owner of the shop, and gives you soap. That's the output. So functions are like that, okay? So now let's go to mathematics. So you have a set, okay, which has the domain, okay? And then you have the image, okay? You have 2 sets. One set is a domain set, and then the image set or the range set, okay? So now you have elements, okay? If you know the sets, of course, I assume you know the sets. You know elements. You have elements in set A and also have elements in B, okay? So here, look at every element is going to an element in B, okay? This element is going to an element in B from A to B, A to B. This is actually a relation, okay? A function is a special relation, okay? A function is a special relation between two sets A and B, okay? It is a special relation. It is a special relation between two sets A and B, okay? It is a relation. Look, there's a relationship here, okay? Of course, I should assume that you also know relations in mathematics. There's a topic called relations and mapping, okay? But that's not a problem. That can be talked about later. So we have this relationship. So now the definition of a function, okay, in mathematical terms is every x, okay, every x a member of A, for every x a member of A, there exists at least f of x a member of B, okay, there exists at least an element f of x which is a member of B for every element in A, okay? So meaning every element in A has a matching in B, okay? For a function to be defined, okay, every element in A should have an image in B, okay? So for every x a member of A, there exists at least an element f of x which is a member of B, okay? So I give you this relation. Let's look at this one, okay? This one, okay, is not a function because, look, this element goes to this element, okay? There is at least one image here. This one goes to this one goes to this. But look at this element, this one. It has no matching in B. So look, this definition does not hold, okay? The definition which says for every element of A, there exists at least an element in B. So this one does not have an element in B. So this is not a function, okay? When you say a relation like this, it is not a function. But look at this relation. This element goes to this point. This element goes to this point. This element goes to this point. This one, this image doesn't have anything from A, but this is a function because for every element in in A, there exists an element x. Okay, for every element in A, there is an element in B, f of x. Okay, so this is a function. Okay, then this kind of a function is called main to one. Okay, you have many elements going to one element. Main to one. Okay, that's a different concept. Okay, so for every element in A, there exists an element in B. That's the definition of a function. All right. Now let's go on and see an example. Look, let's the set AB, okay, A, B, okay, with elements A, B, C, and D, okay, and the set B with elements 1, 2 to 4, okay. Now we have a relation here, A, B, C, and 1, 2, 3, 4, okay. This is set A and this is set B. Now look, this f shows that this is a function. So look, A goes to 2, B goes to 1, C goes to 3, D goes to 4. Now find f of A, okay? Find f of B, find f of C, find f of D, okay? I say find the function of A, find the function of B, find f of C and f of D. Now solutions, okay? Look, this right here is an input set and this is an output set, okay? So for you to have f of A, f of B, f of C, and f of D, you need to have the inputs in set A, okay? Now, what is f of A? F of A is, look, you look at the function A goes to 2. So f of A is 2, okay? When you input A, you get 2, okay? You input A, you get 2. So f of A gives 2, okay? Now, what is f of B? F of B. So when you input B, okay, you use B as an input. Where are you going? When you input B, you go to, you get the output of 1, okay? So f of B is equal to 1. B goes to 1. So f of C, you input C. F of C is 3, okay? C is going to 3. So f of C is 3. Likewise, f of d is 4 because d is going to 4. Okay, so as simple as that. Now, example 2. If f of a is equal to 6 and f of b is equal to -2, f of c is equal to 2 and f of d is equal to 0. Show that in the function relation diagram. Okay, let's show this. So we have we have to have two sets. Okay, one is the input set and the output set. Okay, so what for the inputs we have a, b, c, d. Okay, this inside the f of a we have a, b, c, d. That's the input. Okay, so and the output, it's the one on the other side of the equation. Okay, the left side. Okay, so we have this 6, 2 and -2 and 0. Okay, these are the outputs. So f of a gives us 6, so a goes to 6. F of b gives us -2, so b goes to -2. F of c gives us 2, so c goes to 2. Okay, and f of d gives us 0, so d goes to 0. So this is the diagram, how we can show it. Okay, now let's talk about some of the operations that we can do within functions. Okay, generally a function f is denoted by f of x is equal to y, where x is the dependent variable and y is the independent variable. Okay, generally you find functions denoted by either y or f of x, but normally it's denoted by f of x. Okay, f of x. Okay, f of x just represents an arbitrary function. Okay, it's an arbitrary function. So the definition is for every x a member of a is an input set. Okay, for every x a member of a, there exists at least f of x. Okay, or which is equal to y a member of b. Okay, this is the definition of a function. Okay, so let's talk about the examples of functions, common functions. Okay, y is equal to mx plus c. It's called a linear function. And y is equal to ax squared plus bx plus c is equal to is called a quadratic function. Okay, that's a quadratic function. And then of course we have the trigonometric function, like y is equal to tan x, y is equal to cosine x, and so on and so forth. And then we have complex functions. Okay, and we have cubic functions. Okay, then we have hyperbolic functions, and we have more functions to come, many other functions. Okay, so these are the ones I listed. So now let f of x and g of x be two functions. Okay, if these two functions are defined, of course you can define f of x plus g of x. Okay, when you add two functions you get a single function. Okay, h of x. Okay, when you add to x you get a single function. Okay, so two functions can be added, two functions can be subtracted. Okay, and you get a single function, h of x. Then two functions can be multiplied. Okay, two different functions can be multiplied, you get a single function out of h of x. Then two functions can be divided and you get a single function h of x. Okay, provided the denominator is not equal to 0. Okay, provided g of x is not equal to 0. So two functions can be divided, two functions can be multiplied, two functions can be added, two functions can be subtracted. Okay, we can perform these four operations of mathematics. Okay, example, here we have two functions. Okay, let's say example, f of x is equal to 2x minus 1 and g of x is equal to x squared. Find a, f of x minus g of x, b, f of x plus g of x, c, f of x times g of x, d, f of x divided by g of x. Okay, solution. So f of x minus g of x, so we get our f of x, it's this one, we just put it here. Our g of x is here, we put it here, and then we distribute. Okay, then we have 2x. Okay, here we just get it from outside. Okay, we get it outside the brackets, so we have 2x minus 1 and then we start with the order, okay, which is square of x squared, and go into the constant, okay. So we have minus x squared plus 2x minus 1. This is a single function, okay. We can call it h of x, okay. This one can be plotted on the graph. We can find the range and the domain, which we'll talk about. Okay, now f of x plus g of x, so we get f of x and g of x. F of x, g of x. So I get it outside the bracket. This is where we are now. Then we start with order x squared. So x squared plus 2x squared minus 1. And this is also a single valued function, which is h of x is equal to x squared plus 2x minus 1. Okay, this is actually a quadratic function, and this one is a quadratic function. Okay, we have added a linear function and a quadratic function to get a quadratic function. Okay, and here we have a quadratic function. So f of x multiplied by g of x, so we get f of x. Okay, we multiply with g of x, then we distribute. This one becomes 2x cubed minus x squared, and this gives us a cubic function. Okay, here we go. And then we can likewise divide. Okay, we just get f of x over g of x, and then simplify it to this form. Okay, so this one is also a single function, so we can add, divide, subtract, and multiply functions. Okay, and of course there are things like this, but these ones additionally, okay, like if you talk of things like homomorphism and isomorphism and all these things, you find that this kind of concept like this will be seen. Okay, you talk about this in isomorphisms and I'm mixing Turkish and English. So yeah, now let's see another example. Okay, some examples, okay, with functions. Let's say f of x is equal to 2x squared plus 1, and g of x is x minus 1, and h of x is x squared. Okay, find f of 2. Okay, find f of 1, find f of 0, and also find g of 2, g of 1, and g of 0. Also find h of 1, h of 0, and h of negative 1. Okay, so solution A, we are to find f of 2 first. Okay, so let's find f of 2. Look, we are finding f of 2, so we are putting 2 wherever there is x. Okay, we are putting 2 in place of x. Okay, we are putting 2 in place of x, so we come here, we put 2 in place of x, so it becomes 2 squared plus 1. Okay, 2 squared is 4. Okay, and 2 times 4 is 8. Okay, plus 1, this is 9. That is f of 2. Then f of 1, in the similar manner, f of 1, we are putting 1 in place of x. Look, 1 takes the place of x. Okay, so here we put 1 squared plus 1, 2 times 1. Okay, because 1 squared is 1 plus 1, this is 2 plus 1. Okay, and this is 3. Then f of 0, okay, we are putting 0 in place of x. Okay, so 0 squared plus 1, so 2 times 0 plus 1, this is 0 plus 1, this is 1. Then we go to g. Okay, so g of 2, again 2 takes the place of x, so we are putting 2 here, so it is 2 minus 1, which is 1. Okay, again g of 1 here, here g takes which place? The place of x takes, g of x is x minus 1. Okay, now 1 here takes the place of x, so when we put 1 here, it becomes 1 minus 1, 0. Okay, likewise, because g of x is what? X minus 1, so 0 takes the place of x. So here we put 0 on in place of x, minus 1. So we have 0 minus 1 is minus 1, okay? H of x, h of 1, okay? 1 takes the place of x, okay? 1 squared, it is 1. H of 0, h of x, by the way, is x squared. So 0 takes the place of x, so it becomes 0 squared, which is 0. And in the similar manner, this is the function. So minus 1 takes the place of x, okay, which is minus 1 squared, okay, which is minus 1 times minus 1, and this is plus 1, okay, positive 1. Yeah, that's the introduction to functions, and we will continue later. Okay, thank you.